do em you observe the following. The wage you have to pay the workers, let's say $10,000. Yeah, for $10,000 you can hire a worker. And if you observe the following, if with the current level of labor input, your VMPL is $12,000. All right, then what should you do? What should you do in this situation? What should you do? You can see that your VMPL, the value of marginal product of labor, is greater than the wage, right? And in this situation, you should increase the labor input until the VMPL decrease to the level which is equal to $10,000, until it is equal to $10,000, right? That is the point, right? So think about the fact that the value of marginal product is something like the marginal benefit, the wage rate is something like the marginal cost, yeah? And the rule of optimization is that we should make decision at the point where we have the marginal benefit equal to the marginal cost, right? Similarly, talking about the use of capital, the manager of the firms should use a quantity of capital until the value of marginal product of capital equal to the rental rate. Yeah, the rent payment to obtain the capital unit. So suppose I denote VMPK, it is the value of the marginal product of capital, and R stand for the rental payment, right? We have VMPK equal to R. And once again, you might think that VMPK is similar to the marginal benefit of capital, and R is the marginal cost, right? And we have VMPK is equal to the price of the product times the marginal product of capital. Okay, that's it. Pretty simple. If you understand the basic idea of optimal decision is when marginal benefit equal to the marginal cost, and this would be quite clear, right? Okay. Now let's move on to the next point. We are going to look at the following pretty famous principle of economics. It is the law of diminishing returns. The law of diminishing returns. It tells us about the following: the marginal product of an additional unit of output at some point would be lower than the marginal product of the previous unit of the period. So it actually means that we have an U inverted shape for the MPL or MPK. Yeah, they look like this, right? At some point, for example, here's point A and point B. You can see that at point B, yeah, the MPL at point B is lower than the MPL at point A, right? That's why we say that the marginal product of an additional unit of output at some point would be lower than the marginal product of the previous unit. And of course, you might think of about another example in your daily life. And once again, suppose you have the following. You look at the example of drinking water. Yeah, let's take a look at an example of drinking water. You can usually observe that when you drink the first glass of water, your marginal benefit is greater than your marginal benefit from drinking the second glass of water. Okay, the first one will give you a greater value than the second glass of water. All right. Now, and the same story is true in the production process. Yeah, at some given point, the marginal product of an additional unit of output would be lower than the previous one. The profit maximization input tell us about the following. It tells us that to maximize the profit for the company, the manager should use the level of input at which the marginal benefit equal to the marginal cost. So I have told you about this point. Yeah, should make decision when MB equal to MC. And if we have the marginal cost of labor is W, the wage, right? Then the marginal benefit is VMPL, right? So the rule is VMPL equal for W when we talk about the labor input. And if we talk about the capital input, the use of capital input, then previously we have pointed out that VMPK should be equal to the rent R, right? Ok, rồi chúng ta tóm lược lại một chút. Thực ra ở đây chúng ta nói về về một luận điểm, đó là tối đa hóa lợi nhuận. Đúng không? Chúng ta biết là mục tiêu hoạt động của doanh nghiệp là tối đa hóa lợi nhuận. Nguyên tắc của điều này được thể hiện như thế nào khi mà tiếp cận từ góc nhìn chi phí? Tiếp cận khá đơn giản. Nguyên tắc chung trong quá trình ra quyết định đó là lợi ích cận biên thì phải bằng chi phí cận biên, MB cùng MC. Ở đây chúng ta có hai đầu vào, đó là lao động và tư bản. Đó. Như vậy thì lợi ích cận biên từ tư bản nó phải bằng chi phí cận biên cho tư bản. Hay cái khác là value of marginal product of capital equal to the rental rate. Và tương tự như vậy, lợi ích cận biên từ lao động, value of marginal product of labor should be equal to the wage rate. Tức là lợi ích cận biên từ lao động nó phải bằng với chi phí cận biên cho lao động. Cái nguyên tắc chung này khá đơn giản. Nếu mà chúng ta nhớ cái tư tưởng chung là MB equal to MC trong kinh tế để ra quyết định. Right? Here we have the algebraic forms of production function. There are three commonly used algebraic function to discuss about the production of the company. Namely, the first one is called the linear function. The second one is called the Leontief function. The third one is called the Cobb-Douglas function. The linear function have the following form. We have Q is output equal A times K plus B L, yeah, where we have A and B are constant. If you look at this functional form of the production, you can see that the linear function actually it makes the following assumption. It tells us that K and L, the two input in production, are perfectly substitutable. Yeah, so you can substitute K for L and vice versa. You can substitute L for K. yeah, to obtain the same level of output. Now, the Leontief function Q is the mean of AK BL, where A and B are constant. The Leontief function assumes that the input K and L are used in a fixed proportion. In a fixed proportion, it actually means that K and L are not substitutable. Are not substitutable. Right? Substitutable. Right? Okay, so let me give you an example about Leontief function. Suppose you have the example as following. So we have a pair. Look at the shoes. Yeah, the example, very intuitive example is shoes. Suppose you have one right, one left, and one right shoe, right? So we will have one pair. One pair is going to be usable. If you have the two left, one right, yeah, the usable pair is only one. Usable is only one, because the second left shoes is going to be useless, right? So for example, once again, if you have 5 left and 2 right, 5 left, 2 right, the quantity of usable pair of shoes is going to be the minimum of this. It is going to be 2 only. Okay, so it means that the Leontief function assumes that the input K and L are going to be used in a fixed proportion. Yeah, and we say that K and L are not substitutable. In our example, you cannot substitute the right shoe for the left one, and similarly, the left one for the right one, right? The third function, the third production function forms is called the Cobb-Douglas function. It takes the following: Q equal K to the power of A and L to the power of B when A and B are constant. Actually, the third function, it is somewhere between the two extremes of linear function of perfectly substitutable and Leontief of non-substitutability. The Cobb-Douglas function allows us to have a certain degree of substitutability, right? So what do I mean? I mean the following. We have the two extremes. One extreme is perfect substitutability. The second extreme is non-substitutability, right, of the input. And here is the linear function, and here is the Leontief function. Okay, the Cobb-Douglas function is somewhere between. Here's the Cobb-Douglas function between these two extremes. It allows a certain degree of substitutability among the inputs, right? So, and often the case in practice, the economists often use the Cobb-Douglas function to discuss about the cost of production, the combination of input, right? Tức là gì? Ở đây chúng ta quan sát ba cái dạng hàm sản xuất phổ biến được sử dụng khi các nhà kinh tế thảo luận về cái việc sử dụng các đầu vào cho hoạt động sản xuất. Cái hàm sản xuất thứ nhất là hàm tuyến tính, linear function, có dạng là Q bằng AK cộng BL. Đó. Bản chất là hàm tuyến tính này nó giả định rằng là K và L là có thể thay thế hoàn hảo cho nhau theo một tỷ lệ nhất định nào đó, tức là không có lao động thì thay thế bằng tư bản, ngược lại không có tư bản, không có máy móc thì chúng ta có thể sử dụng lao động thay thế, đúng không? Thay thế hoàn hảo. Thế còn hàm Leontief thì giả định rằng là lao động tư bản nó phải sử dụng theo một tỷ lệ cố định. Như thầy lấy ví dụ với các em để dễ tưởng tượng, thì chúng ta cứ tưởng tượng là những chiếc giày phải, giày phải và giày trái chẳng hạn, đúng không? Nếu mà chúng ta có hai chiếc giày trái, một chiếc giày phải, thì chúng ta vẫn chỉ có một output duy nhất, đó là một đôi giày thôi. Chúng ta có 5 chiếc giày trái, hai chiếc giày phải, thì chúng ta chỉ có hai đôi giày thôi. Đó, tức là use in fixed proportion, theo một tỷ lệ cố định. Thế còn cái hàm sản xuất Cobb-Douglas thì nó dung hòa giữa hai cái cực đoan này, tức là gì? Nó giả định rằng là tư bản và lao động có thể thay thế cho nhau nhưng không phải thay thế hoàn hảo, thay thế ở mức độ nhất định, đúng không? Và cái hàm sản xuất dạng Cobb-Douglas thì nó tương đối đúng nếu mà chúng ta quan sát thực tiễn cuộc sống, tức là có hai đầu vào, đúng không? Lao động và tư bản, hai đầu vào đó thay thế cho nhau ở mức độ nhất định, không thay thế toàn hảo nhưng ở mức độ nhất định. Ok. Right. Now let's have an example of the following production function. Suppose a firm have the following production function. Have this one. Q equal 3K plus 6L. Yeah, and of course you can see that it is a linear production function, right? And it means that K and L are perfectly substitutable, right? Now what's next? We have to answer the question. How much output is going to be produced when we have 3 units of capital and 7 units of labor to be employed? So pretty simple. You plug in, K is going to be equal 3 and L is going to be equal 7. Okay, so here is going to be answer for this question. We have the output is going to be 51 unit. And why do we say K and L are perfectly substitute? Because if you reduce the use of L, you can substitute by increasing the quantity of K, yeah, to maintain the same level of output, right? Okay. Now, based on the discussion of the functional form of production, here we are going to give the formula for marginal product and average product based on the functional form. If we have a linear function, then you can see that the marginal product would be equal the marginal product of capital MPK is going to be equal A, and the marginal product of labor is going to be equal B. Why? Because once again, we write down the equation. Q is equal A K plus B L, right? We have MPK, the marginal product of capital, is defined as the derivative of Q with respect to K, right? So it is going to be equal A. And similarly, we have MPL, is the derivative of Q with respect to L, and it is equal to B. Okay, so if we have the production function is the Cobb-Douglas function, then we have MPK is going to be equal to this one, and the MPL is going to be equal this one. All right. Now let's move next. Here's an example. Yeah, here's an example. And they say the following. They say that we have a firm that produce the output according to the following production function. Q is a function of F of 1 and L. Yeah, and it is equal 1 to the 1 to the 4th, L to the 3 divided by 4. All right. And they ask you the first question, according to this production function, which would one, what is going to be the fixed input? What is going to be the fixed input? You can see that the fixed input is here. Yeah, it tells us that K is the fixed input and L is going to be the variable input. Why? Because if we change L, then the output will change, right? So the answer here is capital is the fixed input. Yeah, and once again, I have told you that we often assume that in short run, capital is fixed. Right? Capital is fixed in short run. Right. The second question, they ask you, what is the marginal product of labor when 16 unit of labor is high? In order to answer the question, let's remember that we have MPL. It is the derivative of Q with respect to L. Okay, so you do the computation. Yeah, here there, and we will find that, and it will substitute back the L to be equal 16 unit, and get the number of MPL equal to 3 divided by 8. Okay. Right, so let's have a break. Let's have a break for 10 minutes, right? Right, let's turn back. Let's turn back. We have seen an example of MPL computation, right? Using the coupled class function, right? Now let's move further. We are going to graphically to use a model that graphically illustrate the optimal combination of inputs that minimize the cost of production. First of all, here we have a concept. It is called the isoquant. Isoquant. It is the combination. It is a combination of inputs that yield the same level of output in the long run when all the input are variable. Right. So once again, if you look carefully at the definition of isoquant, and I want to stress on the point that it is the combination of inputs, yeah, that allow the firms to attain the same level of output when all the input are variable, when we can change the input, right? The next concept is the marginal rate of technical substitution. The marginal rate of technical substitution, it is the rate at which the firms can substitute between the two inputs, maintaining the same level of output. And the marginal rate of technical substitution, sorry, here is not S, it is L, right? MRTS of K to L is equal the marginal product of labor divided by the marginal product of capital. All right, so I know that it is quite hard to understand. Now let's take a look at the graph. We're going to look at the graph. Here's the graph. We have the two inputs, K and L. K and L, yeah, capital and labor input. Here's the shape of an isoquant. Right, isoquant. It tells us that suppose at point A, we use this quantity of capital and we use this quantity of labor input. At point B, we use this quantity of capital and this quantity of output, right? And the fact that the point A and point B are on the same line, are on the same isoquant, it means that at point A and point B, the quantity of output is equal to 100, right? QA equal to 100, QB equal to 100, right? Because based on the definition of isoquant, it tells us about the combination of K and L that give us the same level of output. Right. Now let's move on. If you move from A to B, if you move from A to B, right? A to B, point A to point B, it means that we are substituting labor for capital. We are substituting labor for capital. We are going to use less capital. We use less capital and we use more labor input, maintaining the same level of output, which is equal 100 units. Right? Here's another isoquant. It is Q2, and you can see that the Q2 is further from the origin. Yeah, here's the origin. Yeah, Q1 is closer to the origin. Q2 is further from the origin, and it tells us about the fact that with Q2 we have a greater amount of output. Yeah, Q2 tell us about the combination of input that give us the output equal to 200 unit, 200 unit of output. And similarly, Q3 give us 300 unit of output, right? So you can see that once again, the further isoquant from the origin tell us about a greater level of output, right? And all of this to be called the family of isoquant, family of isoquant, Q1, Q2, and 3, right? Increasing the output. Now let's define the marginal rate of substitution, the marginal rate of substitution. Right? Recall that previously we have the following formula for marginal rate of substitution, and we define it as the absolute value of the slope of the isoquant. Okay, now let's take a look at the graph and explain it graphically. All right, we have the MRTS KL, right, is the absolute value of the slope of the isoquant, Why we are talking about the absolute value? Because you can see that the isoquant, it is downward sloping. It is downward sloping, right? Downward sloping line. And it means that the slope is negative, right? Negative. Okay, now let's explain. Suppose at point A, if we decrease the use of labor input, for example, we decrease the labor input by 1 unit and increase the use of capital by 1 unit, we are going to move from point A to point B, maintaining the same level of output, which is equal 100, right? From point A to point B. Now let's take a look at the slope of the line. The slope of the line is equal the change in the capital divided by the change in the quantity of labor input, and is going to be equal to -1. All right, and the MRTS in this example is going to be equal 1. It is the absolute value of the slope of the isoquant. It tells us that if we decrease the labor input by 1 unit, increase the substituting capital for labor input, increasing the quantity of capital by 1 unit, then we can maintain the same level of output. Now let's further look at this graph. Suppose we are at point C, right? We decrease the use of labor input. We decrease the use of labor input once again by 1 unit. Delta L is equal to -1 by 1 unit. But to maintain the same level of output of 100, we have to sharply increase the use of capital input by 3 unit, right? So what you can observe in this situation, you can compute the slope. Once again, you can compute the slope, which is equal to delta K divided by delta L, and it is equal to -3. And we say that MRTS, the marginal rate of technical substitution, is equal to 3. We decrease the use of labor input by 1, then we have to use more the capital input. We have to use 3 units of capital input to maintain the same level of output, right? And this rule moving from point A to point B in comparison with the movement from point C to point D, it is called the rule of diminishing marginal rate of technical substitution. Yeah, diminishing marginal rate of technical substitution. Oh, now let's move further. Here we are going to discuss about the ISO cost line. ISO cost line. Yeah. The ISO cost line tells us about the combination of input that can be bought with the same amount of money. With the same amount of money. On here I say it is a combination of inputs that yield the same cost. All right. Imagine we have the following. C, it is your budget. It is your budget, the money budget. Right? It's your budget. And you can spend your money to buy the two input, labor or capital. Right? So L is the quantity of labor, W is the waste rate, K quantity of capital, R the rental rate. Right? So here's your budget, and you spend on L and K. Right? So that's why the definition, look at the definition of ISO cost line. It is a combination of inputs that yield the same cost. If we want to draw on the graph, recall that we want to draw in the following way. Is the quantity of K, is quantity of L. So we need to rearrange this equation, and we get this one. K is equal C divided by R, subtract W divided by R times L, right? And here, this is the intercept, and here is the slope of the line, the slope of the ISO cost line. Yeah, minus W divided by R is the slope of the ISO cost line. And if W and R is positive, and of course you can see that the ISO cost line is downward sloping. Yeah, because here we have the negative sign. Okay, now here it is. Here's the graph. We have the following graph, right? And here's our ISO cost line. Here's our ISO cost line. You can pay attention on the following. If you look at the intercept with the y-axis, you can see that it is C divided by R. It is C divided by R. All right. What does it mean? It means that when the quantity of labor input is equal to 0, the quantity of labor input is equal to 0, then all the budget would be spent on capital, right? So C divided by R is the maximum amount, of capital used. Okay, and similarly, if you look at the intercept of the x-axis, C divided by W, it tells us about the fact that when K equal to 0, then all the money would be spent on the labor input. Yeah, and C divided by W is the maximum amount of labor input to be used in the production. Okay, so pay attention on the intercept. Pay attention on the intercept, right? And here is the the equation, the function of the isocost line. Yeah, and once again, I told you that the slope of the line is minus W divided by R. Minus W divided by R is the slope of the isocost line. Now let's take a look at the following. We are going to analyze the changes in the isocost, the changes in the isocost. All right, it looks like following. Suppose initially we have the budget of C0. It is our initial budget, the amount of money that available for us to buy capital and labor inputs. Now, if we have more money, suppose we have the budget of C1. C1 is greater than C0. Here, say C1, right? Then what would happen? On the graph, we show as a shift of the isocost line to the right, right? And you pay attention on the following. You look at the intercept with the y-axis, you can see that it is C1 divided by R, right? And the intercept with the horizontal axis, it is C1 divided by W, all right? See? And you can see that the slope of this line remain unchanged, right? Because we do not have any change in the wage, or we do not have any change in the rental rate, right? So this line tells us about less expensive input bundle. This one tells us about a more expensive input bundle. All right. Now let's move on to the next situation. Here we are going to have a change in W, in the wage rate. Yeah. Suppose we have an increase. Suppose we have an increase in the wage rate. What do I mean? I mean that we have W1 is greater than W0. All right. So if you look at this graph, we have the change in the intercept with the horizontal axis. Yeah, you can see that C divided by W0 is greater than C divided by W1. Okay, we have a new intercept, right? So what did we observe? We observe the following. When the wage increase, then the isocost line will rotate. Yeah, it will rotate. Let's say clockwise, right? The slope is changing. Yeah, you can see that we have a changing slope. It is going to be steeper. It is going to be steeper. All right. Similarly, let me describe a similar situation with the change in the capital input in the rental rate. All right. Let me illustrate the situation. Yeah. So suppose initially we have the following graph, K and L, and here's the isocost line. Here it is. Here's C0 divided by R. Yeah, here's C0 divided by W. Now R0, sorry. Suppose we have a change in the rental rate. Suppose we have the rental rate, let's say to decrease. So what would happen? We have the intercept of the ISO cost line and the vertical axis will change. Okay. For example, let me draw it again. We are going to have this point is the new intercept. It is C0 divided by R1 because we have R1 is going to be smaller than the initial R0, right? So we have the ISO cost line will rotate, it will rotate clockwise, yeah, in this situation, okay? So once again, what is the key point? The key point is that the ISO cost line tell us about the budget available to us to consume the capital input and the labor input. And if we have an increase in the budget, it tells us about the shift of the ISO cost line to the right, right? And if we have a change in the wage or a change in the rental payment, it will rotate the ISO cost line clockwise or counterclockwise, right? All right. Sorry. Now let's further move on with the rule of cost minimizing combination of input, right? The rule of cost minimizing combination of input is going to be pretty simple and quite intuitive. It tells us about the following. The manager of the firm should produce at a given level of output, to choose the level of output where the marginal product per dollar spent is equal for all input. So we have two input, right? K and L. So the marginal product per dollar spent on capital should be equal to the marginal product per dollar spent on labor. Yeah. So let me write down is the marginal product per dollar spent on labor, right? And this one is the marginal product per dollar spent on capital. Okay, on capital. We have MPL divided by W is the marginal product per dollar spent on labor. And we have MPK divided by R is the marginal product of capital. Sorry, it is a marginal product per dollar spent on capital, right? If we rearrange this equation, we are going to have this one. And once again, it is quite intuitive. It tells us about that the marginal rate of technical substitution should be equal to the ratio of input prices. We know that MPL divided by MPK, it is the slope of the isoquant. It is MRTS. Yeah. So MRTS should be equal to the wage rate divided by the rental rate, right? And recall that graphically, we have the MRTS tell us about the slope of isoquant. The ratio of input prices, it is the slope of the ISO cost line. The ISO cost line. Okay. Now, graphically, it looked like the following. Here's the ISO cost line. Here is our ISO cost line. All right. Here is an ISO quant. Right? And you can see the following. At point B, at point A. Point A tells us about an inefficient production. Inefficient combination of input. Yeah, let's say inefficient combination of input. Why point A is an inefficient combination of input? Because if you look at this graph, if the firms choose a point which is, for example, let's say point B, yeah, point B, what can you observe on this graph? You can see the following. At point B give the firms the same output, yeah, because point A and point B are on the same line of isoquant, and which give them the output of 100 units, yeah. But point B lie on the lower ISO cost line, yeah. Point B is on a lower ISO cost line, and it requires only the budget of C2, and C2 is smaller than C1, right? If you produce at point A, you have to spend C1 amount of money. If you produce at point B, you have to spend C2 amount of money, right? So point B is the point that tells us about efficient combination of input that help us to minimize the cost of production. Now, let's once again look at this point. Look at point B. What is the characteristic of point B? Point B is the tension point. It is a tension point between the isoquant and isocost. Yeah? And because of the fact that it is a tension point of the isoquant and the isocost, then at point B, we have the slope of isoquant to be equal the slope of isocost line, right? And we know that the slope of isoquant is the marginal rate of technical substitution, MRTS, and the slope of isocost line is W divided by R. Okay, so the rule is simple. The manager should choose the point where we have MRTS equal to the ratio of input prices, W divided by R. MRTS equal W divided by R. Right? So here it is. Yeah, here is the rule of choosing the cost minimizing combination of input. Now to summarize, let's discuss the optimal input substitution. The rule is pretty simple and very, very intuitive. It says that to minimize the cost of producing a given level of output, the firms should use less of an input and more of other input when that input price. Right. Let me make this statement a little bit differently. We know that we have two input, K and L. Yeah, and the price of K is R. The price of L is W. And the rule is clearly pretty simple. If the wage increase, yeah, the price of labor increase, we should use more capital and we should use less labor. Yeah, pretty simple. All right. Let's think about the following situation. You can see that in many countries like China, Vietnam, many developing countries, they face the following problem: the problem of increasing wage, right, around the world, and especially in rapidly developing country, they're facing the problem of increasing wage. And to solve these problems of increasing wage, the rule of optimal input substitution tells us that we should use more K and we should use less labor input. All right. And that's why in practice, people are now talking about the following. They are talking about the automation. They're talking about automation. It means that there's a trend of substituting robots, which is K, for labor input. Yeah, and the process of automation exists in many industries, even in some very labor intensive industry like textile or apparel industry, right? Let's take a look at let's watch the following video to explain the point. Let's wait a minute. Yeah, I'm going to give you a video as an illustration for our discussion. All right. Okay. So here it is. This video will give you an illustration about the automation in the fashion industry, right? In the fashion industry. And I told you that traditionally, people believe that fashion industry is quite labor intensive. Yeah, it means that we use a lot of labor in this industry. But due to the fact that the wage in this industry is rising, and the firms in this industry are trying to substitute robots for the workers, right?
The automation revolution is beginning to come into fashion. The clothing industry is among the latest economic sectors to be making the leap, which is ironic because it was among the first to be mechanized. Today, they still require skilled human hands to guide and handle the materials. In this episode of Moving Upstream, our third on the robotics revolution, we're looking at what these new cutting-edge technologies can do and the impact they're beginning to have on the developing world. Across the globe, 60 million people toil each day in the garment industry. It offers the poor women in particular, job opportunities they might not have otherwise. The journal visited garment factories in Bangladesh. They employ more than 3.5 million people, most working for little more than the country's minimum wage, around $64 a month. And sometimes toiling under conditions that endanger their lives.
There has been another horrific incident at a garment factory in Bangladesh.
At least 112 people died.
Hundreds of injured were rushed from the scene.
Now a new threat is emerging to workers' livelihoods. Machines that automate parts of the clothes-making process. This German-made robot, for example, is knitting sweaters for brands like H&M and Zara. In January, WSJ's John Eabd visited garment factories in Bangladesh.
I would visit factories in Dhaka where workers would work manually to make sweaters while automated machines would also work to do the exact same thing. And it was quite clear that the workers were going to be replaced by these machines. And I would ask the workers, are you afraid that your jobs will be taken away by the automated machines? And they would say, yes, we're scared.
Until recently, machines lacked the versatility, the dexterity to handle soft materials that comes naturally to humans. But thanks to machine learning and other forms of AI, what you're seeing here may be just the tip of the needle. New types of machines capable of ever more complex tasks are on the way. Machines like these threaten to make the situation worse for a country in dire need of more jobs. Bangladesh, according to the World Bank, needs to add 2 million jobs a year to keep pace with its expanding labor force. But the number of new jobs added by the garment trade has fallen to 60,000 a year. When you zoom out a bit, you see a region bursting at the seams with people needing work. Close to 1 million individuals are projected to enter the workforce here every month for the next 2 decades. By one estimate, if automation reaches its potential, some countries could lose more than 80% of their garment, textile, and apparel manufacturing jobs. How worried are you for countries like Bangladesh?
I'm very worried, given that their economy is dominated 85% by the garment industry.
Carrie Nordland, a professor at Brown University, teaches about the impact of globalization on women.
Because women have these jobs and often are the sole breadwinners for their families.
The sole breadwinners?
That's right. They've been able to lift their families out of the depths of poverty. Those low-skill jobs may become extinct very soon.
Eric Brynjolfsson, who studies the economic impact of what he calls the second machine age, thinks the only solution for these countries is education.
They're going to have to leapfrog and get up to the level that Europe, the United States, Japan, and other advanced countries have, and that's not an easy task. Technology can help there too. We have online programs at MIT.
Some of these people aren't even literate.
That's right.
So a lot of these women have very basic reading, basic math skills. So where will these women go? Will they have opportunities for retraining? This is the open question.
Fortunately for them, societies that employ massive armies of sewers still have some time. Autonomous sewing machines aren't nearly as far along as, say, autonomous vehicles. On a recent trip to Japan, we visited a company that's been taking intermediary steps in the autonomous direction. That's where we visited Yuho, a company that's been working for decades on the challenge of replacing sewing machines with machines that do the sewing. This is Akihisa Takagi, the 77-year-old founder and chairman of Yuho.
ミシンを踏んだことのない、触ったことのない人でも我々の機械ですと即そういう作業が行える。
Yuho's machines automate some of the more time-consuming steps.
この機械は 自動でどんなパターン、このパターンがサイズとかいろんな形に多少形状が変わってもですね、サイズが変わっても自動でコンピューターでコントロールして縫ってしまう。
Yuho suggested that we visit a place where we could see some of its machines in actual practice. They sent us to a prison. What kind of uniforms are they making here?
刑務官の制服を縫製しています。
At Nagasaki Prison in Japan, Yuho's machines help the inmates, whose faces the prison authorities required us to blur, meet their daily quotas. And how much training do you need to be able to use one of these?
1日で十分ですね。
They use this one, for example, to add pockets to uniforms, a job that would otherwise take 3 people and a lot more time to complete. The inmates must produce at least 50 pairs of pants and coats per day. Yuho's owner tells us his machines are used in China, where labor costs are rising, to help make clothes for Uniqlo. But the developing world hasn't been all that interested, he says, because the price tag for them is so high. Cost is one reason why automation in the garment industry may take root first in the West. One US company called Software is aiming to do something Yuho has not, removing almost entirely human involvement in the process of making, to start with, t-shirts. The company provided this footage of its prototype Sobots. Software touts that its Sobots will bring garment production back to America. By the end of 2018, it plans to open a factory in Arkansas capable of cranking out over 1 million t-shirts a year. At prices the company says are on par with the lowest wage countries in the world. So the day when Sobots, from start to finish, can produce articles of clothing appears to be not so far upstream. What do you think? Will these technologies have a dramatic impact on the US and on the developing world? We'd love to hear your comments.
All right. So you have watched the video, yeah, and it tell us about the automation in the textile industry. Sorry, in the textile industry. Have any question? Understand the point, right? And once again, I want to stress. Let's emphasize on the key point. We know that the task of a manager is to choose the optimal combination of input, right? So imagine the two following case. Here is the total cost for production. If this company A, right, use a small portion for capital and a last fraction for labor input, and let's compare with company B, which choose to use more capital. Let's say this portion, more capital, and they are going to use less the quantity of labor input. If we compare the company A and company B, it will observe the following. For company A, they are going to have a low in short run. I mean, we're analyzing in short run, a low fixed cost in short run. Yeah, because they use less capital. They're going to have a higher variable cost in short run, right? So it is going to be quite easy for them to adjust the scale of production, all right, because they have quite high variable costs. For the company like company B, you can see that they have quite high fixed cost, right? They have a quite low variable cost, And as a consequence, it is going to be more difficult for them to adjust the scale of production. All right. Let me give you the example. For example, in the textile industry, it is a labor intensive industry. Textile industry, labor intensive, and in the oil industry, it is capital intensive. So we can see that in textile industry, it is easier for the firms to change the scale of production, right? For the company in oil production, in oil industry, it's going to be harder to change the scale of production, all right? Do you understand? Have a question?
Thầy nói lại
Have any
đoạn
question?
cho rõ lắm.
Nói lại đoạn nào em nhỉ? Cái đoạn vừa rồi hay là
Không, cái
từ
đoạn
từ chỗ nào?
vừa rồi đó.
Tức là ví dụ như ý tưởng của nó này nhé. Thực ra thì về mặt logic, về mặt tư tưởng thì doanh nghiệp có hai lựa chọn, đó là khi mà họ quyết định lựa chọn cái công nghệ sản xuất ấy, thì họ có thể lựa chọn phương án là labor intensive hoặc là capital intensive, tức là sử dụng nhiều lao động hoặc là sử dụng nhiều máy móc. Cái ưu điểm của phương án lựa chọn sử dụng nhiều máy móc ấy, sử dụng nhiều lao động ấy là gì? Là khi đó thì chi phí cố định sẽ thấp và chi phí biến đổi variable cost là lớn. Ưu điểm của phương án này đó là có thể dễ dàng thay đổi quy mô của hoạt động sản xuất. Ví dụ như là khi mà thị trường đi xuống nhé, thì em dễ dàng làm một việc đơn giản thôi, đó sa thải lao động để cắt giảm chi phí. Đó. Nhưng với cái máy thì em không thể sa thải cái máy được. Với cái máy không phải là thứ mà có thể dễ dàng sa thải nó được, đó. Vì nó là fixed cost. Thế còn từ đó mà chúng ta thấy là với những doanh nghiệp mà hoạt động trong những ngành sản xuất sử dụng nhiều máy móc, hay người ta gọi là capital intensive industry, thì chi phí cố định là lớn này, chi phí biến đổi là thấp này. Do vậy những doanh nghiệp trong ngành này sẽ gặp nhiều khó khăn trong việc thay đổi quy mô hoặc hoạt động sản xuất. Đây thầy lấy ví dụ nhé. Thầy lấy ví dụ như thế này thì các em, thầy nghĩ là các em sẽ dễ tưởng tượng hơn rất là nhiều này. Ví dụ như đây. Đây, ví dụ như các em nhìn vào cái đồ thị giá dầu thô. Thầy lấy cái khoảng thời gian là 5 năm đi. 5 năm. Em quan sát thấy một đặc điểm như sau này. Vào thời điểm tháng 4 năm 2020, khoảng tháng 4 năm 2020 thì giá dầu thô là âm. Một điều rất là đặc biệt trong lịch sử. Một điều rất là đặc biệt, phải nói rất là đặc biệt trong lịch sử. Em có nhìn thấy không nhỉ? Đây cái thời điểm này này. Nhìn thấy chưa nhỉ?
Dạ. Lúc nào?
Rồi, nó âm khoảng 37 38 đô gì đấy. Âm khoảng 37 38 đô. Âm có nghĩa là gì? Một cái mặt hàng nào đó mà bán với giá âm có nghĩa là gì? Có nghĩa là người bán, nó người ta trả tiền cho người mua. Em có thấy nghịch lý không nhỉ? Đúng không? Người bán trả tiền cho người mua. Thế tại sao lại xảy ra cái sự kiện này? Nó rất đơn giản thôi. Nếu mà chúng ta sử dụng cái lý thuyết khung lý thuyết của chúng ta là để giải thích. Ví dụ như oil production, tức là ngành khai thác chế biến dầu khí, là cái ngành mà sử dụng nhiều tư bản, nhiều máy móc. Do vậy thì cái khả năng mà điều chỉnh hoạt động sản xuất ấy, nó không nhiều. Nó dẫn đến hiện tượng là gì? Ví dụ như cái giai đoạn tháng 4 năm 2020 là cái thời điểm mà dịch bệnh bùng phát ở các quốc gia phương Tây, là nơi mà cái nhu cầu sử dụng dầu thô rất là lớn, ví dụ như Hoa Kỳ, ví dụ như châu Âu, ví dụ như Trung Quốc. Thì điều gì xảy ra khi đấy là cái nhu cầu sử dụng dầu thô giảm mạnh, trong khi nguồn cung không thể điều chỉnh giảm với mức độ tương ứng. Đó. Nó dẫn đến hiện tượng là các kho dự trữ dầu thô ấy, nó đều bị quá tải, không còn chỗ chứa nữa, dẫn đến là người bán, người ta phải trả tiền cho người mua để người mua mang dầu đi. Em có hiểu cái logic này không nhỉ?
Đã hiểu rồi.
Ok. Tức là một cái sự kiện rất là hy hữu trong trong lịch sử để các em quan sát và cảm nhận cái ý tưởng đó, đúng không? Tức là với những cái ngành mà sử dụng nhiều máy móc, hay người ta gọi là capital intensive industry, thì cái khả năng điều chỉnh cường độ sản xuất ấy, nó không phải là dễ dàng, bởi vì máy móc nó thường phải vận hành một cách là tương đối ổn định, không phải là chúng ta cứ thích thì chúng ta ấn cái nút là nó vận hành, không phải như thế. Nó phải chạy liên tục ngày đêm, nó phải chạy liên tục ngày đêm. Tất nhiên là có dừng để bảo dưỡng, nhưng mà nhìn chung là nó phải diễn ra một cách liên tục. Nó khác hẳn với những ngành mà sử dụng nhiều sức lao động. Thì nếu mà sử dụng nhiều sức lao động ấy, thì người ta có thể điều chỉnh cái cường độ sản xuất tương đối linh hoạt, một cách tương đối linh hoạt. Đấy chính là cái ý tưởng ở trong phần này. Ok, câu hỏi nào nữa không nhỉ?
Không ạ.
Rồi, thế thôi. Thế hôm nay chúng ta dừng ở đây, thì hẹn gặp lại các em vào thứ sáu nhé. Chúc các em giữ gìn sức khỏe.
Dạ vâng ạ.
Ừ. Rồi, thầy chào các em.
Em thầy ạ.
Thầy chào các em.
Em chào thầy ạ.